Alrighty, good morning, students. I guess that I don't know it's morning, but I just like saying good morning, so I'm gonna keep rolling with it. And welcome to 3.6 part 1. So I actually decided to break up 3.6 into 2 lectures because I remembered that piecewise functions are kind of tricky, and so I would like to spend one whole video focusing just on piecewise functions. Piecewise functions kind of make me excited because the word piece, for some reason, just reminds me of like a piece of cake. And I love sheet cakes. So anyway, there's today's tangent. But we have 3.6, graphing piecewise defined functions. Oh, this we are doing later. And our objectives are to graph piecewise defined functions. Homework problem set 3.6 part 1 on Math Lab. And then this video will be linked. All of this will be linked so you can just click away and get everything done. So part 1, and only part, is graphing piecewise defined functions. Sometimes functions are defined by 2 or more expressions or pieces. Such functions are called piecewise functions. So if we look at our first example, it says evaluate f of 2, f of negative 6, and f of 0 for the function f of x equals 2x plus 3 for x is less than or equal to 0, and negative x minus 1 for x is greater than 0. Write all answers in ordered pair form. So the first thing we notice about this is that our function looks a little bit different than anything that we've ever seen before, right? It looks kind of weird. And it's hard for me to actually type these in the way that they're normally written. So this would actually normally be written like this. It's going to be f of x is equal to curly bracket, and then 2x plus 3 for x is less than or equal to 0. And then the second function actually goes below it. So it's going to be negative x minus 1 for x is greater than 0. So this is actually what they look like. I just have a hard time. Actually, you can't type piecewise functions on Google Docs. So maybe I'll write email complaint form or something. But moving along, let's go ahead and look at what we're asked to do in the question, the key to math. What are they asking us to do, right? So they want us to evaluate f of 2, f of negative 6, and f of 0. So this is just like when we are asked to evaluate like f of 2 for the function x squared plus 6x or something like that for f of x equals x squared plus 6x. We know for in that case, we just plug in 2 for x, and that's how we evaluate it. So we're going to do the same thing when we have piecewise functions. So when we're asked to evaluate f of 2, we're just going to go ahead and plug 2 into our function for x and see what number we get. However, the kind of curveball to piecewise functions is that we have to look at the second part right here, right? So x is less than or equal to 0, and then x is greater than 0 for the bottom one. So if we're thinking about 2, all we have to do is figure out which domain, this top one or this bottom one, I'll label them 1 or 2. So sometimes we can even think of these piecewise functions as 2 separate functions, right? So 1 and 2. So if we're thinking about f of 2, is 2 within the domain of function 1 or the domain of function 2? Well, 2 is greater than 0. So 2 is going to be in the domain of function 2. So that means that f of 2 is going to equal negative 2 minus 1, because again, it's falling within the domain of function 2. And so I'm going to plug in 2 for x. And when I plug in 2 for x, I get negative 2 minus 1, which is equal to negative 3. And then the final step, since we're asked to write answers in ordered pair form, is that I know my x value, which I plugged in for x, is 2. And my y value, which I just solved for, is negative 3. So that is the answer to number 1. All right, what about f of 0? Okay, well, does 0 fall in the domain of function 1 or function 2? Well, it's going to fall in the domain of the function that has the inequality that includes the equals, right? So that's going to be this function 1, because x is less than or equal to 0. So when we're equal to 0, that's going to fall into the domain of 2x plus 3. I plug in 0 for x. 2 times 0 plus 3 is equal to 3. And so I know that my coordinate point for f of 0 is going to be 0 for my x value, and 3 for my y. And then finally, f of negative 6, I guess I did this in an odd order, but that's okay. F of negative 6, okay, where's negative 6 going to fall? In the domain of function 1 or function 2? And again, they're not actually separate functions. So when I say function 1 and function 2, it's all just one function, but sometimes it helps to think about them as separate when we are evaluating or graphing. So f of negative 6 is going to fall into the domain of this top guy, right? X is less than or equal to 0. Negative 6 is less than or equal to 0. So if I plug in negative 6, I'm going to get 2 times negative 6 plus 3, which is equal to negative 12 plus 3, which is equal to negative 9. And so my coordinate point here is going to be x is negative 6 and y is negative 9. So that is how I evaluate piecewise functions. Again, it all comes down to looking at the domain. That is really important. And then you just say, okay, well, my x value is within this top domain, or oh, my x value is within this bottom domain. And then you just plug and chug away, evaluating functions just as normal. No problemo there. So now we're going to think about what we do to graph piecewise functions. And what we do is we just do it one piece at a time. So first I'm going to draw myself a nice little coordinate plane with some points. And again, I'm going to rewrite my piecewise function in the correct way. Shout out Google Docs, not 2x plus 3. X is less than or equal to 0, negative x minus 1, x is greater than 0. Okay, so the first piece that I want to graph, that I'm going to graph, is going to be that top piece. So 2x plus 3 when x is less than or equal to 0. So if I'm looking at my x-axis, which I will go ahead and label x, even though I'm sure you all know, you all should know, x and y. So if I'm thinking about my x-axis, x is less than or equal to 0, I know that that is going to be this entire part of the axis, because that's where my x values are less than or equal to 0. So that means that that top part, 2x plus 3, exists on the left side of my graph. So I'm going to go ahead and graph 2x plus 3 on that left side. Thankfully, my equation is already in slope-intercept form, so that's easy, because I know my y-intercept is going to be 3, and my slope is going to be 2. And instead of counting rise over run and moving this way on my graph, I actually cannot do that because I know, oh, my graph doesn't exist over there. So instead of counting rise over run, I'm going to think about it as, okay, it's going to be over 1 down 2. Because again, if I start at this point, I would have rise 2 over 1. So then if I do that again, I'm going to go over 1 down 2. Because again, if I started here, it would be rise 2 over run 1. So then I have some points. I'm going to sketch my graph, and my line is going to be looking something like that, and it's going to keep going down that way. And you'll notice that I have a closed circle on my y-intercept. That's because at x equals 0, this function does exist because my inequality is less than or equal to 0. On the other hand, when I go to graph this guy, negative x minus 1, that exists when x is greater than 0. So that's going to be this part of the x-axis, because I know that for that, the right part of the axis, that's when x is greater than 0. And so now I'm going to go ahead and graph that line. And again, it's also in slope-intercept form, which is nice. But the thing about this one is negative x minus 1. So if I go down to my y-intercept at negative 1, I'm actually going to put an open circle. Because this function, the domain is x is greater than 0. So it does not equal 0. So I have to put an open circle to indicate, okay, I know that my domain does not include this part. And then my slope is going to be negative 1. So that's going to be rise over run is just going to be 1 over 1. But again, my line is going to be this way because it's negative. So instead of going up 1 over 1, I'm going to go down 1, down 1, down, down. And then I'm going to sketch my graph kind of going somewhere like that. Because remember, again, I'll draw this. This was from one of the other lectures. This is a negative slope, and this is a positive slope. So that's general reference, just something you should know. Positive, negative. Maybe that mirrors and doesn't look right for you. But that is graphing piecewise function. Again, it's just graphing functions separately on the same axis, basically, and making sure that you're paying attention again to the key, which is the domain right there. So now at the bottom, there's another example, and I want you guys to go ahead and work through this one and bring any questions you have about it to class, and we can go over it then. So thank you for watching. More practice in the homework. Hopefully you are able to get piecewise functions down. And if you don't and you need some more review, I'm more than happy to do that. Yeah, have a wonderful day. Well, I guess maybe you're watching this at night, but either way, I'm gonna stop screen sharing and stop recording.